Hello. So in this video, stress analysis of a truss, 2D truss, எப்படி analyze பண்றது? So this is a 2D truss problem. So here the area is given as a 3250 and Young's modulus is given, that is a 200 gigapascal. So we have to find out the resultant force and the stress in this simple truss. So here the key point number 1 and 7 are fixed condition. So the 1 is fully fixed and the 7 is a roller support, right? We have to apply roller support on this seventh key point. So that is the important thing in this problem, and we will try to solve this problem by hand calculation also, and also verify the result of both conditions, simulation and hand calculation. So let us start this problem. So first we have to do a structural in the preference and the preprocessor. It is a element type. Here the link element must be selected because we do not perform this by using the solid element, right? Here there is no solid data to solve this problem, so we are having only a line, right? So we have to select link element. So add link and link 180, and the real constant. In that real constant we are going to enter area, that is 3250, that is the area. And so in this problem, one more important thing is the distance is given as in meter, right? And area is in millimeter square. So I am going to convert this meter into millimeter and then applying it in the ANSYS. Here gigapascal is also converting into Newton per meter square. So then only we will be able to solve calculation easily. So I am converting this into millimeter and Newton concept. Now the material property, structural linear elastic isotrope. Here the property is 2E5, that is 200 gigapascal is converted into 2 into 10 power 5 Newton per millimeter square. And Young's modulus is not required for the link problem, that is 0.0. And in the modeling session I am going to do with key point. So the first key point is 0, and the second key point, that is 1800 and 3118, and similarly it goes on up to the key point 7. So in active CS the second key point would be 1800 in x direction, and the 3118 is y direction value, and the third key point is 3600 0, and the fourth one 5400 3118, right? And the fifth key point is 7200 0, and the sixth key point 9318, and the seventh key point 10800. So the key points are applied with help of this diagram. Now I'm joining this key point with the help of a line, a straight line. So like this, I joined this key points and then meshing. So I don't want to use this mesh tool. I directly mesh using this mesh option, manual size. Here the lines are selected. So with help of the all lines. So here the division should be 1. Division should be 1 because the load applying point are at this end points, right? So I do not want to split into 2 lines. So I just want to split into 1 line. So division should be 1 and click mesh and key point here pick out. So the element 1 cannot be used. Sorry. Here the line pick out. So now the line is meshed on the solution analysis type. Do analysis, it should be a static one. Define load, apply structural displacement on key point. This key point should be all degree of freedom, and this key point should be y direction because it is a roller support. And force at key point 1 is minus 280 into 10 power 3. Just click apply, and this point, that is this third point, is also this point is also 2800, and this point should be 2100, and this point should be 36 into 10 power 4. Now solve the current load step. The solution is done. Now come to the general post processor. Here nodal solution, that is here the list result. Under the list result, reaction solution. So all structural item, or that is all item. So we can get the value, that is Fy is 513.513 into 10 power 6, 0.616 into 10 power 6, right? So these two values are obtained in the reaction solution. And apply the element table, and we have to find out the stress value by using this element table. And here the element table, first we have to define the table with help of this sequence number. So click by sequence number LS1, that is load step 1. Now list element value LS1. So we will get the value of the various key point, various element points, right? So we have to verify this with help of the hand calculation. They already solved the calculation value. So we have got that 616 point something, so which is 617 into kilonewton, and also similarly 513, that is also equal. And here also we are getting the point that is stress at point 1 is 82.8. Here also 82 point, right? So we have got same value for both simulation and calculation. Thank you.